So hi guys, welcome to my channel, and today we are going to solve Codechef Cook-Off June 2020 problem per capita income. So let us see what the problem is. Okay, so there are n provinces which are connected by m bidirectional roads. Okay, so for each I, the road connects province UI and VI. So there is a province which is connected by a bidirectional road for a pair of UI comma VI. Okay, so it is possible to travel to any direction in this particular road. That is why it is bidirectional. You can traverse from particular city UI to VI and from city VI to UI as well. Okay, so the annual income of the ith province is AI and its population is BI. So basically we are given the annual income and its population. There is a per capita income of some province and which is lower than the other province. So the king of Sheffland wants to know that how many province it can include in its kingdom so that its per capita income is maximized. Basically he wants to have all the provinces which will increase its per capita income, and he wants to have only those provinces which will give us the maximum per capita income. Okay, the sum of annual income of the chosen provinces divided by the sum of their population would be the maximum. So the sum of the total income of all the provinces that he chose divided by the sum of the population must be maximum in that particular case. Also what he wants is it should also be possible to travel from each of these chosen provinces. The provinces that he chosen, each and every province must be having a way to get from any other province. So he wants that there is a possible way to travel to each province from a particular province. Among all such ways to form the new kingdom, the king would prefer the number of chosen provinces to be as large as possible. So basically in this question he wants to have all the provinces such that its per capita income is maximized and he can travel from one province to another, and also he wants that all the provinces that he chose, it should be maximum, like it should have maximum number of provinces in its kingdom. So these are the conditions of the problem. So we need to design this kingdom and we need to print out the number of provinces possible and print that particular province in a given order. And if there are more than one answer, like if you got more than one answer, you can choose anyone and print that. So this is the problem. Okay, so what are the observations that we can derive from the problem is chef want to select the provinces that its per capita income is maximized. So chef wants the provinces which will increase its per capita income, and he wants to have maximum per capita income with him. The second is chef also wants to select maximum provinces, like he wants to have maximum provinces in its area. So these are the observations that we can derive, then these are the points on which we'll form a solution. So the task 1 is what will be the criteria of selection of provinces. So how we can choose the provinces, right? So this is the task 1 to get. So let us understand this particular task with the help of an example. So what do we do in this when we have questions like this is we'll get to know that this question must be related to graphs, because it has been given a bidirectional road and this problem must be related to graph. But now we need to develop the logic that how this particular graph is working. So first what we'll do is we'll take the examples and see how the provinces are being selected and how the provinces are selected. So basically what we have been given is income and population. So let us see what is the per capita income on all these provinces. So we get to know that if we divide income and population, the per capita income in this example must be 3, 2, 2 and 3. Why? Because we'll divide income with population. So we'll get per capita income. Alright, so but chef wants to have different provinces, and let us see how we can get different provinces. Like if we select these two particular provinces, then what will be the per capita income for chef? The per capita income for chef is 27 by 11. We'll add these two values and then we'll divide by the summation of these two values. So the per capita income of the chef will be 27 by 11, which will be equal to 2.45. So one observation is that 2.45 is the value if we combine these two values, and earlier if we only take this value, that is 15 and 5, the per capita income was 3. So the per capita income was greater earlier, and if we combine a value which is less than this particular value, the overall value decreases. So this is the first observation that we can make. Let us see another example. If we combine these two values, then what will be the per capita income? So earlier the per capita income of this was 2 and this was also 2. So if we combine these two values, then the per capita income remains stagnant, it will be 2. So This is the second observation that we can make. If we have per capita income of some states and if we combine them and the overall per capita income does not change, it remains stagnant. Now let us see the last example. If we combine these two values, then what will be the per capita income? Earlier the per capita income was of this particular province was 2 and of this particular province was 3, and if we combine these two, the overall per capita income decreases to 2.64 from this point of view. If we see that this particular state this particular province has a per capita income 3, but if we take a value which is less per capita income and combine these two values, then the overall per capita income reduces. So what observation is are we getting from this example is that if we take a value with a certain per capita income and if we'll add a province with a less per capita income, the overall per capita income of a subset reduces, right? So this is the observation we can make, and the per capita income of a particular subset remains between the lower value, the lowest value of any province in that subset, and the highest value in that particular subset. So the per capita income remains between these two values. So this is the observation that is quite important in this particular example. Okay, so that is also summarized here, that if we take the average of per capita income of different provinces, it will be less than the maximum per capita income in that subset. So that is what we got using this example. So how the approach, what is the approach that we can make in this problem is, we can think of observations like what we just did before, that we have taken an example and wrote the observations. So we have thought from this observation, what we can derive from this observation is, we can get maximum per capita income from different province when we take a province of maximum per capita income from others, right? So like in this particular example, if we only took this particular province, then this particular province has a maximum per capita income, that is 3. That's what the chef wants. Chef wants maximum per capita income, and if we took only this particular state or this particular state, then it will give it the maximum per capita income, and if we combine any other state with a lower per capita income, that will overall reduces its per capita income. So solely chef wants is maximum per capita income. If in this particular problem the only task was to give him the maximum per capita income, then what we'll do is we'll return this particular state that okay, this state is giving him the maximum per capita income. So this is the one observation that we got by just reading the examples. But chef also wants to have maximum number of provinces in him, right? So chef also wants maximum number of provinces to be in his kingdom. So it is simple. What we can do is we'll select all the provinces which have per capita income as the maximum per capita income. Like in the previous example, if we see that these two have maximum per capita income, so what we can do is we can combine these two states and form a particular kingdom. So let us see how we can do that. So what we'll take this state, this particular province and this particular province, and we'll combine this. So what was the average per capita income that we are getting is 15 plus 48 divided by 16 plus 5, that is the population, and the resulting is 3. So earlier also it was 3 for these two states, and now if we combine these two states with maximum per capita income, then also the per capita income is coming 3. So I think the approach is clear now. What we'll do is we'll select all the states with maximum per capita income and combine these states and then form the particular solution. Okay, so the task is very clear. The task which we choose was how to select the province, and now what we got is we'll select the we'll select the provinces with maximum per capita income. So I'll summarize the approach. Calculate the per capita income of all the provinces, take long double. Why? Because what we'll do is we'll get the answer in points. Like for example, some of the province is having the per capita income of 3.25 and some are having 3.21. So but 3.25 is greater than 3.21, so we'll take long double in that case and find the maximum per capita income and find all the provinces which has the same maximum per capita income. So what we'll do is we'll find the maximum per capita income first, and we'll find the states which are having the maximum per capita income. Now what we'll do is, the third condition for the chef was that there must be a possible way amongst these states, right? So it might be possible that some of the provinces are not connected to other provinces, right? So what we'll do is we'll check that how many provinces are connected to each other. So how we can check this is by applying DFS to these provinces. So what we'll do, we'll apply depth first search to these provinces. So in this particular video, I am not going to explain what depth first search is. If you want to know more about depth first search and other algorithms of the graph, what you can do is you can check out my playlist of graphs for competitive programming. I'll provide the playlist link in the description, so you can check it and explore the algorithms. Okay, so now we'll quickly dive into the coding part. So in this particular part, I am maintaining two arrays of long double, that is one of population and one of income, and I'm getting the input of that. Now I'm taking the magsync variable, which will have the maximum per capita income amongst all the per capita income. So in the long double t variable, I'm calculating the per capita income for the ith province, and I'm getting the maximum per capita income in this magsync long double variable. Now I'll make a vector, and in this vector I'll get all the nodes which have this particular magsync, that is maximum per capita income. So I'll match it. If the particular province has this magsync per capita income, then I'll mark it. I'll make an array of n length, and I'll mark that particular node as 1, and I'll push that node in this vector. So this is all that I'm doing in this part of the code. Now in the second part of the code, what I'm trying to get is I'll make a vector which is final, which I'll print at the end of the solution, and I am making a visited array which we'll use in DFS part, and I am running a loop over the magsync node size, that is the size of all the provinces which have the maximum per capita income. Now I'll push that particular province in the temp vector, and I'll see that if this particular province is visited or not. If it is not visited, then I'll call DFS over this particular node, and if it is visited, I'll continue. Why? Because getting a DFS over this particular node, it will include the time complexity. If this particular node is visited, it will again and again call DFS over this node, so the TLE will occur. And if this particular node is not visited, and then I'll call DFS over this node. Now in the temp, what I'm getting is I am getting the path of the maximum subset of connected nodes from that particular node which I included in maximum inc node. So from that node I am getting the maximum part from DFS which is connected. So if this temp size is greater than the final size, initially the final size is 0. So if this temp size is greater than the final size, what I'll do is I'll copy temp to final, because I am getting a larger subset of the nodes which has connected and which has the maximum per capita income and which will be included in the kingdom. So I'll copy that temp into the final, and at last I'll clear that temp, and then I'll run over the other node. So at the end of the solution, I'll print the size of these nodes, because it is the size of the kingdom which I have included, and I'll included the provinces in this final size. So I'll print that final size, and why I'm adding 1 to this, because I have maintained the indexing as 0, but in the question the indexing from 1 is required, so I'll add 1 to it. And at last, it is the standard DFS code that I made. So what I'm trying to get is I'll mark first visited 1. If the particular node is visited, I'll mark it as 1, and I'll run it over the size. I have maintained a vector of vectors for the edges, and I'll run it over the size, and I'll see if this node is visited or not, and if the mark is 1 or not. Mark is 1 because the node which will be included in the kingdom must have the maximum per capita income, which I have marked in the earlier part of the code. So I'll check it if this node is marked or not, and if this node is marked, I'll push that particular node into the temp matrix, and I'll call this recursive call of DFS again, and I'll mark it as visited, and again I'll call DFS, and this whole process continues. So if you want to understand the in-depth process of DFS, that how a DFS works, you can always check my video on DFS, and the link to the video is given in the description. So this is the code, and this is the explanation of the Codechef long challenge problem. So if you have any doubts, you can always comment us in the description, in the comment section below. You will get a reply, and you can also send us your doubt in the form of email through the links that we have provided in the description. So at last, thank you for watching. Please do like, share and subscribe my video. Thank you.